All right, welcome into today's daily AP chemistry question. So feel free to pause the video if you would like. Set a timer for about 1 minute and 30 seconds, maybe a little less for this one. This should be a little bit of a quicker question, and give it a try. I'm going to go ahead and go through the solution. So which of the following correctly shows how the 3p electrons fill the orbitals in sulfur? So sulfur's right here on the periodic table. So its electron configuration would be 1s2, 2s2, 2p6, 3s2, and 3p4. So this is the 3p section right here. Because we're in the third row, which is the third energy level, and then these rows over here, or columns I should say, is your P. So 3p, and then sulfur is the fourth element into that. Okay, so that means it has 4 electrons in the 3p. So, and then because p can hold up to 6 electrons, p has 3 orbitals. So that's why each of these options, there's 1, 2, 3 of those horizontal lines. Those are our orbitals. Okay, so p has 3 orbitals because it can hold up to 6 electrons, but there's not actually 6 electrons in the 3p orbitals for sulfur. We're in the 3p sublevel. So we can rule out C, because the arrows in this notation of orbital diagrams represent the electrons. So C represents 6 electrons in the 3p. Sulfur only has 4 in the 3p. So we can rule that one out. We're also going to rule out D because when 2 electrons are in the same orbital, they have to have opposite spins, which we represent by them one pointing up, one pointing down. So D does not follow that. So it's not D either. So A and B are the 2 most common ways that you'll see students draw this. But the correct answer is A. Correct answer is A, because now in both cases, these have 4 electrons, and in both cases, they follow the Pauli exclusion principle, which is the principle that says they have to have opposite spins if they're in the same orbital. But there's a third rule called Hund's rule. Okay. And actually, I didn't really mention the first rule, which is the Aufbau principle, which just states that they fill kind of the lowest energy levels first, which is why it fills 1s and then 2s, so on. But this is really about Hund's rule. So Hund's rule says that if you have multiple equal energy orbitals, which is what we have here, these 3 orbitals are all equal energy because they're all 3p, same energy level and sublevel. So this is 3p, this is also 3p, this is also 3p. So they have the same amount of energy. So Hund's rule says that they're going to fill, if you have multiple electrons filling up these multiple equal energy orbitals, they're going to fill one at a time first, and actually with the same spin, which is okay because they're in different orbitals. So when you have, when you're filling 3p orbitals, you're going to put your first one in the first one, and then your second electron in the second orbital with the same spin, third electron in the third orbital with the same spin. And then if you have a fourth electron, as we do in sulfur, then you'll start pairing up with opposite spins. Okay, and then if you had 5, it would look like this, and if you had 6, it would look like that. So A is the correct answer. It's never going to look like B because they don't start pairing up until all three of the p orbitals have at least one electron in them.